listening to the Virtuous Machines podcast. In this podcast, we dive into the world of AI and philosophy, learn from each other, and help building a world where ethical and responsible AI bring us together. My name is Amir Kiani, and I'm your host on this podcast. Hello, everybody, and welcome back. This episode, and likely a few more to come, are dedicated to one of the most pressing and under-discussed topics in tech and geopolitics, AI ethics in warfare. A lot of people worry about AI becoming conscious, turning against us, or wiping out humanity, but often we ignore a more immediate danger, our own misuse of AI, especially in war. That threat isn't futuristic. It's already here, and it's been growing long before generative AI stole the spotlight. According to the Institute for Economics and Peace, over 90 countries are currently involved in some sort of conflict, directly or through proxy. And many of these conflicts depend on advanced technologies, with AI playing a major, though often invisible, role. So today we are turning our attention to the ethical challenges of AI in military contexts. Because while much of the conversation about AI ethics centers around chatbots and biases in recommendation algorithms, the stakes are much higher when the same technologies are used to surveil, target, and kill. With that in mind, today's episode takes us from medieval clockwork to predictive drones, from radar bunkers to decision-making machines. This isn't just a story of innovation, it's a story of shifting responsibility, moral risk, and what happens when the machines we build start making decisions about life and death. Just a quick note before we dive in. Most of the technologies we'll explore in this episode are focused on developments in the United States. That's partly because the US has led many of the most documented and publicized advances in military AI. But many other countries are building and using similar technologies, from China and Russia to Israel, the UK, and beyond. The global race to integrate AI into defense and intelligence is well underway. For millennia, engineers and military leaders have shared a common dream: replace the fallible, exhausted human with tireless, obedient machine. And so ancient militaries built trigger mechanisms, early siege machines, naval mines, and anything to make the use of force more efficient and more certain. But even then, the machines weren't autonomous. They did not decide on their own. They extended human power, but not human judgment. Fast forward to World War II, and you'll see analog fire control computers that could track aircraft trajectories and suggest the perfect moment to fire. Germany built the V-1 buzz bomb, an early cruise missile that flew a prison distance before descending. The Allies, meanwhile, connected anti-aircraft guns to radar systems, an early glimpse into what now is called closed-loop automation. The systems didn't decide, still, but they were getting faster, more integrated, and a speed would soon become a new kind of weapon. Now let's step into the Cold War. Imagine a vast underground bunker filled with whirring machines and green radar screens. This was SAGE, the semi-automatic ground environment, a vast network that linked radar stations to central computers, enabling real-time tracking of Soviet bombers. SAGE was fast, not in miles per hour, but in information. This was the dawn of sensor fusion and real-time computing in war. We were no longer just moving metal, we were moving data. According to the book In Athena's Camp by Hundley from 1999, this era saw the birth of the so-called revolution in military affairs, or RMA. Not a single technology, but an integrated approach: smart weapons, network sensors, and real-time decisions. The idea was this: he who sees faster kills faster. But crucially, humans were still in the loop. Every target, every kill still needed that final okay. According to Bruce Hoffman in chapter 15 of that book, and I quote, "The revolution in military affairs, it is argued, heralds a new era of warfare dominated by the American military's mastery of the conventional battlefield. Just as gunpowder, the mechanization of battle, and atomic bombs previously changed the fundamental conduct and nature of warfare, so will a combination of technological progress, doctrinal sophistication, and innovative force employment in turn renders existing methods of conducting warfare obsolete. The assumption that the United States Armed Forces alone will have the compatibility to harness all the elements of this revolution is in large measure derived from the demonstrated superiority of American combined arms over the much larger Iraqi forces during the 1991 Persian Gulf War. Well, that's what changed next. The U.S. Department of Defense's 2007 Unmanned Systems Roadmap predicted a new world, one where machines would not just follow orders, but understand context, collaborate with the other machines, and adjust to new missions mid-fight. This was the transition to cognitive automation, machines that learn, that adapt. No longer just fast or accurate, but situationally aware, from mechanical gears to neural nets, from trigger wires to autonomous mission planning. This was the beginning of something new, not just new in form, but in kind. Now let's talk about the rise of drones, DARPA, and Project Maven. It's hard to overstate how much the Predator drone changed warfare, not just the tactics, but the entire moral architecture. Developed in 1990s as a surveillance platform, the Predator drones became a weapon after 9/11. Armed with Hellfire missiles, it could loiter for hours over enemy territory, track targets, and strike, all controlled remotely by operators continents away. As Paul Scher notes in the book Army of None from 2018, what made the Predator revolutionary wasn't just its flying ability, it was its ability to collapse the kill chain. See, traditionally, the steps from identifying the target to executing a strike involved layers of communication. The Predator drone reduced that chain to a few minutes. But let's be clear, it wasn't autonomous. It was a flying robot on a long leash. The leash was, nevertheless, held by human analysts and pilots. What came next was DARPA. The Defense Advanced Research Project Agency, or DARPA for short, is where tomorrow's tech was born. In the early 2000s, DARPA began developing what you might call the brain behind the drone. Projects like CALO, or Cognitive Agent That Learns and Organizes, were designed to build software that could learn, adapt, and organize complex tasks. According to the wiki page on CALO, and I quote, CALO was an artificial intelligence project that attempted to integrate numerous AI technologies into a cognitive system. The name was inspired by the Latin word calo, which means soldier or servant. The project started in May 2003 and ran for 5 years, ending in 2008. Essentially, calo is an intelligent assistant that helps users by organizing information, creating documents, supporting communication, managing tasks, scheduling, and allocating resources. It learns from user behavior to model priorities and relationships. Sound familiar? That's because calo became the foundation of Apple's Siri. And then came Project Maven in 2017. Project Maven, officially known as Algorithmic Warfare Cross-Functional Team, is a Pentagon project involving using machine learning and data fusion to process data from many sources, identify potential targets, display information through a user interface, and transmit human decisions to weapon systems, among other functions. In effect, it uses AI to process the vast ocean of drone footage, video feeds too large in volume for any human to analyze. The algorithm will scan the footage, flag anything suspicious, like vehicles, people, and buildings, and then send it up the chain. More specifically, Project Maven integrates diverse data sources, such as satellite imagery, infrared sensors, metadata, synthetic aperture radar, and intercepted communications into a unified system. Machine learning, particularly object recognition, is then used to analyze over 4 million human-labeled military images to detect targets like tanks or military facilities. The main user interface visualizes movements, logistics, and strike-no-strike zones, and can relay human decisions to weapon systems. Originally developed in collaboration with Google, the partnership ended in 2018 following internal protests. Since then, over 21 companies, including Palantir, which provides the core platform, Amazon Web Services, Microsoft, and Maxar, have contributed to the project's technical ecosystem. Now, let's talk about the decision cycle. The classic framework is the OODA loop: observe, orient, decide, act. Originally built for fighter pilots, this model was human to its core, but AI is fracturing it. Shar, in the book Army of None, lays out a clear hierarchy. Manual systems, they are fully human controlled. Remote systems, humans guide them directly. Supervised autonomy, machines operate under oversight. But full autonomy, the machines decide and act alone. Here's a real scenario. A loitering munition identifies a radar signal, confirms its enemy, and strikes, all within seconds. No phone calls, no generals, and no pause. As the 2007 roadmap predicted, systems now adapt, replan, and execute without human input. So as you can see, these systems have been long predicted, and in fact, steps towards them have been taken. Now, as systems grow in autonomy, they grow in number. Swarms of drones can act in unison, making decisions collectively. There is no commander in the loop, just a network. As the book in Athena's camp predicted, the future soldier might not be a soldier at all. It might be a distributed algorithm executing policy through code. And that raises a chilling question. If no one is in charge, who's responsible?
If you have been listening to this point, I want to thank you. I really appreciate it. I also want to ask you, like your friend, to support me and this podcast in any way you can. By subscribing to it, sharing it with a friend or colleague who might be interested, or rating it if you think it adds value to you. Also, if you know people and organizations who might be interested to be on the podcast, please let me know. You can comment here or just go to my website in the description and contact me. All right, let's get back to the podcast.
As we follow the rise of military AI, we have to pause and ask, what happens to the ethics when the decision of war, once made by people, are now handed off to machines? Let's look at 3 of the biggest ethical challenges that automation brings to the battlefield. Number 1, human out-of-the-loop targeting. Can a machine be trusted to decide when to take a human life? Autonomous weapons raise serious concerns because they operate without direct human control. That means they might identify a target, evaluate the situation, and launch a strike without any human in the loop. The just war theory, which has guided military ethics for centuries, demands human judgment, distinguishing civilians from combatants and assessing whether the harm is proportional to the goal. Critics argue that machines lack empathy, context, and accountability. They don't understand right or wrong. They follow patterns, not principles. Some defenders claim AI systems, if properly trained, could actually reduce emotional errors and avoid rash decisions made in the fog of war. Still, the question remains, can we delegate something as morally serious as killing to a system that doesn't know what morality is? An algorithm based on a data that could be biased, that could be making mistakes. And with all the biases and errors, someone's life could be taken. The second item I want to talk about is predictive violence. Is it ethical to use force based on what someone might do? As I mentioned, predictive targeting is already here. AI models analyze behavior, location, and patterns to flag potential threats before anything happens. Drones can be sent to quote-unquote neutralize a person based not on past action, but future risks. Supporters argue that this is necessary in modern conflict. In an asymmetric warfare or counterterrorism, the cost of waiting for an attack can be catastrophic. Why not strike before the bomb is planted? But this shifts the logic of warfare, from response to preemption and from evidence to probability. And probability can be wrong. Even a 90% accurate system implies that 1 in 10 people targeted could be innocent. Ethically, this veers into a dangerous territory. It undermines due process, treats people as statistical threats, and makes the battlefield resemble predictive policing, only with deadlier consequences, of course. Finally, let's talk about accountability gaps. When machines make mistakes, who takes the blame? Simple question, right? In traditional warfare, we can trace responsibility. Orders come from a commander carried by a soldier. Simple as that. But with AI, the chain of accountability becomes tangled. If an autonomous drone strikes a school instead of a weapons depot, was it a coding error, a sensor glitch, a failure in oversight, and who answers for it? Some might suggest we need a new legal framework, holding designers, commanders, and manufacturers responsible. Others propose distributed responsibility, where everyone along the development chain shares moral weight. But this risks moral diffusion. When everybody is responsible, no one truly is. And without clear line of accountability, there is no deterrent, no justice, and no opportunity to learn from mistakes. In short, if we let responsibility dissolve into the system, we risk building weapons that no one owns, even when they go wrong. Right, so across these three challenges, autonomous targeting, predictive violence, and accountability gaps, we see the same core issue, the erosion of moral agency. Let's be clear, AI isn't inherently unethical. It can support better decisions, reduce collateral damage, and save lives. But if we aren't careful in designing and managing the systems, we risk using it to bypass ethical judgment instead of enhancing it. Well, to me, the task ahead is quite clear. Keep humans meaningfully involved, build transparent and accountable systems, and treat ethical design not as a barrier to innovation, but as its foundation. Because in warfare, as in life, what matters most is not just what we do, but how we decide to do it. Now, dear friends, what do you think about all this? Are current military AI systems capable of meeting the ethical standards we expect in war? Should we ever allow a machine to make a kill decision? And can distributed responsibility ever truly substitute for individual accountability? Whether you're a technologist, ethicist, policymaker, or a concerned citizen, your voice is a part of this conversation. So please feel free to share your thoughts, critiques, or insights. All right, this wraps up this episode of Virtuous Machines. Thanks for tuning in, and until next time, stay curious and take care.